Well, welcome back to our second lesson from Unit 3. This lesson covers solving inequalities using addition or subtraction. Your learning target is to be able to translate words into inequalities and then also to be able to solve one-step linear inequalities using either addition or subtraction. So we have a couple of properties of inequalities, just like we had properties of equations and properties of real numbers. And one of the things that we can do with inequalities is we can add the same number to both sides of an inequality, and it doesn't change the truthfulness of the inequality. So if we start out with a true statement like 3 is less than 8, we can go ahead and add the same number to both sides, such as positive 2, and that would give us 5 is less than 10. This is still a true statement. So no matter what number we add to both sides, we will still get a true statement. Algebraically, we would write that a plus c is still less than b plus c. As long as a was less than b to begin with, then if we add a number to both sides, the same number, our statement will continue to be true. The same thing holds true for subtraction. We can subtract the same number from both sides and we'll still have a true statement. So this time let's subtract 5, and 9 minus 5 gives us 4. 12 minus 5 gives us 7. Since 9 was less than 12, when we subtract 5 from both sides, we still have a true statement, 4 being less than 7. Algebraically, we would write a minus c is less than b minus c. So let's go ahead and do some practice problems. Our directions say to translate each sentence into an inequality. And the first one says the difference of 3 and a number is less than 0. So the words that you need to recognize, difference is a significant word in math, and is less than 0 is also a significant phrase. So there is one caution here I wanted to remind you of. If we have 3 less than 6, that translates to 6 minus 3. But notice, just by putting the word is in front of the words less than, that means the inequality. 3 is less than 6 versus 3 less than 6. So that's a very, very small detail that's very, very important for you to translate your words to inequality. So don't forget to pay attention to that. So when we have the word difference means we're going to be subtracting something. So we're going to subtract the difference of 3 and a number, so we'll just call it n, we don't know the number, is less than, so we have the word is, so we're going to go is less than 0. Now, it does not say to solve this, it only says to translate it. So for these problems, that's all you need to do is translate. Letter B says the sum of a number and 1/3 is at most 5/6. Well, the sum means something's going to be added together. What are we going to add together? A number, so we don't know it, we'll call it n, a number and 1/3. Those are the two things that we're adding together, is at most. So that means it can't be bigger. So that means is less than or equal to, is at most 5/6. Okay, it can't go over 5/6. It has to be less than, but it could be equal to that. Number 2 says solve the inequality and graph the solution. So we have a number plus 9 is less than 15 is how we would read that. We're going to be solving these the same way we solved equations. Our goal is to get the variable by itself. So I'm going to go ahead and just highlight the variable. This is what I'm trying to get alone. And so we'll go ahead and work on isolating that variable on one side. So 9 is being added to the variable. So I want to do the opposite and subtract 9 from both sides of the inequality. I only subtract it one time from both sides. So a plus 9 and a minus 9 add to 0. I still have an x on the left-hand side. Keep your inequality the same. You just bring that right down. 15 minus 9 is 6. So this is my solution. Now I need to graph the solution. How does that graph? Well, I need the number 6 on my number line. I'll put the number 6 down here. And then it says it's less than. Any numbers less than 6 are solutions. It does not include 6. There's no equal to with that. So it's an open circle and it points to the left. So I want the arrow that goes to the left to be part of my solution. So those are all solutions, the ones that go to the left. Let's work on letter B. It says D minus 3 is greater than negative 6. Well, again, I'm trying to isolate the variable. My variable is the letter D. Okay, trying to get that alone. So I want to see what's happening to letter D. 3 is being subtracted from D, so the opposite is to add 3. And whatever I do on one side of an inequality, I have to do the same operation on the other side. Bring down your inequality, it stays the same. Negative 3 plus 3 add to 0, and then bring down your variable D. Negative 6 plus 3 is negative 3. So now we just need to put this on our number line. The value is negative 3, and then we need to figure out whether it's an open or closed dot. There's no equal to with it, so it's an open dot. So I'll grab an open dot for negative 3. And it's going to point to the right. All the values that are greater than negative 3 are solutions. So my arrow will be pointing to the right. So I have a little note here. The next couple of problems, the math is very simple. It's very easy. So my goal for you in providing these problems is not for you to get the right answer. My goal for you is to practice translating the words into inequalities. So please pay attention to that. The recommended daily allowance of iron for a female in Sarah's age group, which is 14 to 18 years old, is 15 milligrams per day. Sarah has consumed 11 milligrams of iron today. Write and solve an inequality to show how many more milligrams of iron Sarah needs to consume to meet her recommended daily allowance of iron. Well, obviously you can look at the problem and read through it and recognize she needs at least 4 more milligrams to reach her recommended daily allowance. The math is very simple. What I want you to be able to do, the skill I want you to focus on, is writing an inequality. Okay? So the recommended daily allowance is 15. She's already consumed 11. So the amount she's already consumed, 11 milligrams, plus some more. We don't know how much more. I'll just call it X for the additional milligrams of iron. And that amount has to be at least, so it could be bigger, greater than or equal to 15 milligrams, right? So X, 11 plus X has to be greater than or equal to 15. So write and solve. So that's our inequality. We also need to solve it. So X right here, we have 11 is being added to X. So we want to do the opposite and subtract 11. Remember, we're trying to isolate our variable when we're solving equations or inequalities. So the 11s add to 0, bring down your variable, bring down your inequality. 15 minus 11 is 4. So this tells us that Sarah has to consume 4 or more milligrams of iron to meet her recommended daily allowance. Okay, if we were to graph that on a number line, let me just go ahead and pick a number line here for you really quickly, and I'll just put that over here on the right. So here's our number line, and we're going to go ahead and include 4 on our number line. This time it has an equal to with it, so we want to include the endpoint 4, so I need a solid dot on 4, right? It's going to look like that. And then we also need to have all of the values that are greater than 4. So we're going to have anything greater than 4, and I'll go ahead and make that green so it looks like what we have. And let's see, that looks like it'll be pretty good. So anything greater than 4 is going to go off to the right. Okay, so that's what your answer would look like for that one. Here's one for you to try. Josh can bench press 220 pounds. He wants to bench press at least 250 pounds. Write and solve an inequality to determine how many more pounds Josh must lift to reach his goal. Again, the math is easy. I want you to focus on writing the inequality, and I have a little hint here for you. 220 pounds plus the additional pounds he wants to lift has to be at least 250 pounds. So I'm going to let you work on that one on your own, and we can talk about that one in class. And that will do it for this lesson. We will see you in class tomorrow.